Good evening, everyone.
Good evening.
Good evening, sir.
Good to see
sir.
you guys again. Evening.
Good evening, sir.
Welcome to class.
Finally, it is now our own time, our own season to meet you finally.
We meet the prop. It's Linux
Yes.
days.
Yes, so, and it's good to know that 13 of you are still standing. Wow.
Engineer.
In fact, more than 13, 15 people still standing. You are the last man standing. I should actually
Yeah, but some people didn't come along with us from Linux. Out of these 15 you mentioned.
Some people waka join us.
Oh, okay. No, one way or the other, you've all been part of class. Maybe from previous classes and from But it's good. It's good to see that this many people understood what we have done so far, and they are willing to go ahead to join the big league. Welcome to IT. This is the real IT. It's going to be interesting. We'll make it, like somebody put it on the forum, as fun as possible. All right, guys, nice to be with you again. So I'm going to assume that the session you had with Obafemi did not happen, so I will start all over. And then we'll spend, we'll spend quality time trying to understand what I call the big picture, rather than just focusing on the technicals. The technical is ultimately the in thing, but we need to understand the place of the technical in, so we know where we stand, especially for interview purposes. It's not enough to know Linux or to know AWS or to know infrastructure as code. It's equally relevant to know what you can do and the place where you stand in the big picture. So when they say, I'm looking for this, you can confidently say, that is my area. Or no, that's not my area. You're probably looking for somebody in this other area, but I'm a DevOps person, therefore it's not a good fit for me. I mean, things like that. All right.
That makes sense, and that will help.
Yeah, it should help. All right, guys, let's start. Share screen will be mostly, what is that? Let me load the pens. Control N. Let's see. Okay. So I'll come back to this and see share screen. Actually, you can start from here. Oh, share the whole screen. All right, guys. So let me share my Word document. That will be your manual for project for DevOps. Can you see my Word document?
Yeah.
All right.
Yes.
Awesome. So prerequisite for this course, you have all covered, not just covered, but covered with me, with the theITern, which is really awesome. I'm happy about that. Knowing that because we trained you, we know that you have actually covered this extensively within the scope of industry requirement. So Linux systems administration, AWS solutions architecting, and then of course, the latest one, infrastructure as code, which is basically your ability to not just do this, implement this manually, but now also implement that in automation mode. That's the difference. All right, so if I say spin up an EC2 using infrastructure as code, you may not know how to write the code, but you know where to go to pull templates that you can customize to achieve your goal. Awesome. All right, so to DevOps now. What is DevOps? So as a DevOps engineer, you are responsible for designing the right infrastructure. Okay, let's see what that means. Let me bring my drawing too. So what we want to do from now is this. Yes. All right, so let's go, guys. So we know that we have cloud, right? So let me represent cloud by that. We have our cloud, and at this level, you already can go from your system, laptop, you can connect to cloud. And then while in cloud, you can either use your console, that is your graphic user environment, to set up your server, configure the server for security. In fact, deeper than that, you can actually set up a whole network of infrastructure in cloud, where you have your EC2 server, or sometimes serverless at introductory level. And then you have your database engine, you have your web server, you have your backend server. Sometimes, most of the time, you have one server doing both jobs. And then you can configure who is able to come into your network from the outside world or even from within cloud, and what IP address is able to go out, the security group around your servers, the auto scaling, so that when there is when traffic attempting to access your application goes beyond a particular threshold, then automatically another server comes up. You're able to register a domain name and map that domain name to the IP address of this server, so that people no longer access that server by its IP address, but by domain name, and so on and so forth. All of that is what makes you what? A cloud solutions architect. Particularly when you no longer do it at the level of console, you are now writing codes here, infrastructure as code, and then you connect to your cloud using what? What's this link called? AWS CLI. AWS CLI. And through that link, link is the best word, you're able to access cloud, and this code is now able to set up your network in cloud and do exactly or even more than you did when you were using console here. So this is the concept of setting up your infrastructure using code. This network in cloud is generally referred to as virtual private cloud. All right? So all of that was not jargon. Everybody understands that, right? That was just way of repetition. Now, taking it from there, the reason you set up this infrastructure, because it's not just server anymore. I mean, it's most of the time we're not just talking server only. We're talking about other things that I mentioned here when I was describing this. We no longer call it just server, we call it infrastructure. It's much broader than just a single EC2. All right. So because we set up that infrastructure, like we knew from the very beginning of this training, the reason for setting up this infrastructure is to run, or actually to deploy, that's the right word now, we'll start to use that word, to deploy your application, your software. We used to call it software those days, but these days it's always about application. To deploy an app there that will solve a problem, such that the whole world, I guess I'm too fast. All right, so let me relax a little. So this will be a solution for a problem that billions, maybe millions of people are interested in. So that from their mobile devices, from their laptops, from their cars, from wherever, they are now able to access this application that is hosted in your VPC, the infrastructure within your VPC. This is the application we're interested in. This is the whole idea of cloud and setting up infrastructure as well. This is the application that you want to deploy. All of this land that you bought, and this house that you built, and these beautiful partitions, this room, this kitchen, the whole idea is to import, to bring in these properties so that you can sit there and relax and enjoy the rest of your life. In this case, instead of houses, we're talking about infrastructure, and instead of properties, we're talking about application. So DevOps now comes into play here. So far, all you know about is infrastructure. But for once, we are going to let you know, we are going to say, actually, for this application to get here, this is what happened. There are people, hundreds, thousands, okay, let's be modest, maybe hundreds of programmers. The modern word for programmers is software developers, or simply developers. So there are hundreds of developers scattered around the world, working for, what's your dream company to work for? You like Elon Musk? Want to work for Tesla? So working for Tesla, all right? So all of these developers are programming for Tesla. This guy in India, when he programs, he pushes, he saves his program centrally. When this guy programs, he saves centrally, and then he closes from work, he goes to sleep. So there is central repository, that's what it's called, that enables collaboration between developer 1, developer 2, developer 3, developer 300, developer 400, and 70, and so on across the world. So there's this repo that they all save to, all right? When by collaboration, by working together on the same project, they save their jobs to this repository, and this program, this codes, new word for code is, for program is code, is centrally available. What you want to do as a DevOps engineer is take that code that have been pushed, pull it, pull the Java codes. We'll be dealing mostly with Java codes. Pull the Java codes to your system, convert this code, use the appropriate tool in your system to convert this code to build this code. Build is the word, I was trying not to use it now, but okay. So you build this code. Building means that you are converting all of the 3,000 lines of code, 5,000 lines of code, 300 by this guy, 1,500 lines of code by this guy. So you have a long line of codes written in Java. So you build all of them so that the result now is just one file, one build file, all right? So all of these codes are compiled into one file. This is the file that you are interested in, that ultimately becomes your application. But at this level, we don't call it application, all right? I'm trying not to use too many technical terms right now. Okay, let's just leave it as application. So when you build the codes, it comes out as just one file. And this is the file that you're interested in. So the codes come in here, through there, and then what happens? A program inside your laptop that you use to pull builds the code, and it comes out with a single file called Artifact. I'm trying not to use it, but at this level, rather than use the wrong word, let me just. So you have your artifact. So by that, you have converted codes to app in codes. And then you now move on. Let's summarize that. You may want to move on to say, okay, this is what the application is going to look like. Let me deploy the application in an environment that looks like this cloud environment and see what it looks like. So you deploy it. Usually at this level, you have gone beyond working with virtual machines now. You deploy this application to a container. And then you see how the application behaves within the container. because this is not the real place, you may want to call this area your test. You are just testing. Is this application really working? Is it behaving like it should behave? When you painted, when a button was coded red, is it really appearing in your browser within the container as red, and so on and so forth? And then once you are satisfied, you may also want to take it to another environment for other people to see. Or let's call this one just nomenclature, not really listed. Let's call this one development environment. And then let's call this one test environment. And then maybe you want to call this one the same, similar environment. Similar environment in terms of the infrastructure that it supports, but different interests. You may want to call this QA environment. And then ultimately, once it is confirmed ready by software testers, by QA testers, by legal people, by all of the different aspects of IT people that are working on this project, then it may now be deployed to this server where the 2 million people that are interested will now see it. When it goes into this server in cloud, it is live. It's live. It's no longer within your development environment. It is now live, and then the whole world can see. So you want to make sure that it's perfectly okay. You are observing all governance, all legal, all kinds of laws that might seize the opportunity of your mistake to sue you or anything, as well as meeting the technical requirement, the minimum technical requirement that you will say, oh, this is a good application. It's meeting the threshold, and then you deploy to this live server. It is this live server through which the whole world can see it that we call production. Production server. All right. So your work as a DevOps engineer is to set up this system that will take, what color have I not used? That will take codes from here, and then pull from here, and then deploy through this whole line and release to production. Not just to build it, but also to automate that process. That is your work as a DevOps engineer. You got it? So we'll be learning. No, we'll not be learning code, because there are people already that are specialized, that already learn how to write codes. They are called developers. So you are working with them. So you'll be taking their codes, and then you are building all the way from there until you deploy to production. So this aspect, usually up to this level, yeah, let us go. So this aspect of the divide is called development. And this aspect, when it goes into the production server and the whole world is seeing it, is called operations. So as the DevOps person, you are the person between development. That's how we normally write the big O in big letter, and operations. All right, automating the process. What does automation mean? Automation means that the minute this guy changes a code and commit is the word, commit that code to your central repo, that should trigger, it should switch something that will now automate the process of converting that code until the change that results from the code change ultimately reflects in production here. That is, and then the concept. Oh, let me take a break there. Make sure you understand what I've explained so far. Yeah, any question? 20 people in class. Was I too fast? Don't worry, we'll repeat all of that in a different way. But if you understood just one thing, just let me know what you understood from all of it.
So when do codes show up at the repo zone or area? Is it when they are fully done with their codes, then they submit it to the repo?
Yes, when they are done for the day.
For the day, okay.
Yeah, IT job never ends, it's continuous. 20 years, 30 years, 50 years, this IT company will still be in production. So every day, or maybe every hour, depending on the company's policy, they push whatever they have done to the repo.
No, because it never ends. Is that why we have continuous integration and continuous deployment?
Correct. But I'm going to assume that you don't know the meaning of those terms for now. But,
Yes, sir.
yes.
Okay.
All right. Okay, so let's explain all of that all over in a different way so that you get what the class is suddenly quiet. All right, so the DevOps engineer is his responsibility to do what I just said. Okay, now let us remove all of this. Or maybe not. Let me use the note. Can you see my note?
Yeah.
Okay. So this part, the part of this, let me go back there. Yes, here. So the part of this pipeline, all right? So this continuation, this, what did I call it earlier on? It's actually called pipeline. So the part of this pipeline, yeah. Let's take the pipeline, this whole process, let's take them one by one. So this is one part. This part, this is the first part, where developers from India, when he's going to sleep, he hands over to India is going to sleep, another part of the world, maybe in the East Coast, is waking up, somebody in California, and then he continues from where this guy stopped. How did they know where he stopped? Because he deposited his last work in the repository. And this guy will wake up in the morning and pull this guy's last job from the repository and continue from line 75, where he stopped, and write the codes up to line 3001. By the time he's going to bed, he will push what he has done there, and then this guy will be waking up in his own part of the world and continuing from line 3005 and so on and so forth. So this part of this job, this part here, is called continuous. It's called version control, continuous version control. That's where this term came from, continuous version control. Why do we call it version control? We call it version control because this repository here is version control. What does that mean? It means that if I save a file there, if I save my code as code1.html, for example, and then I modify code, this guy modifies the code1.html, and he now comes up with a different file, code2.html. This code2 is not going to replace this code1. The code1 will still be there, but will now we'll have the two files. This one will remain, but this one will now be saved in addition to this. It's not like your Word document that when you type page 1, you save. By the time you type page 2 and you save, you now have a new Word document of the same file. No. So version control allows you to have different versions of the same file. Have you experienced that before?
Yeah, that is like versioning in AWS.
Yeah, it's the same version, yes.
Okay.
It's the same version, yeah. That's what I mean, version. Right? It's the same version of AWS. So this system is version control. So there is never a time that you will come and say, I made a mistake in the file that I just uploaded. I need to revert to the correct file that was valid 5 days ago. How do I get it? It would always be here because this is a version control. You would never lose anything. No file is ever thrown away. Instead, the newer version of the file is saved alongside the old file. That is version control. And it's very important in development. When the file becomes useless, you still don't want to delete it. You just want to keep it. In 3 years, 4 years, even if you never use it, version control will save it for you. All right, so did you get this part and do you understand the meaning of continuous version control? It never stops. Every time you push a file there, it does not replace the old file. It just saves it as the file version 3. And then you save another one, version 3.01, version 3.002, version 4, but it just keeps increasing. Version 4 will never replace version 3. All right, I guess you got that now. So continuous version control is this concept of
That's like a storage, right?
yes, it's a storage for your codes.
Okay.
That's why I drew it with this sign. All right.
Excuse me, like this now, just like AWS wants to increase the storage from 8 gig like that or 16 gig, something like that, right?
This is like you are setting up S3 buckets.
Yeah.
So that you can, the whole world, or I mean, as many people as you want can be saving files to that S3 bucket. And it's of course automatically extendable. S3 bucket will never come to you and say, I'm full. No. It will just continue to increase in size for life. Okay. Once you are pushing something there, it will just be expanding. It's auto expand. Okay. As a matter of fact, S3 bucket can be configured to be your auto
your code.
To be your version control to be this. So private companies would rather use S3 buckets. Anyway, yeah, I think let me come back to class. So there are different tools that are available that are already made, ready-made off-the-shelf tool available for version control. Such tools are one, there's popular one they call Bitbucket. Let me refer to them. So we have a Bitbucket. It's an off-the-shelf tool that you can use for version control. We have S3 bucket. Why did I not write it? No, you can create your S3 bucket. S3. You have a GitLab, but the one we'll be using for version control in this project, in this DevOps, the one we have chosen to use, even though all of them are good. The most popular of them is GitHub. We are going to be using GitHub for our version control. So everybody would have a GitHub account where we'll be version controlling our codes. I'll make the codes available to you that will be using. This class is full of projects. By the end of this class, you should have, by the end of DevOps1, you should have at least 7 projects in your GitHub account that you would have practiced, mastered, and be confident to present at interviews as projects that you have completed on your own. All right. So do you understand the meaning of version control now? And the tool that we are going to use for version control?
Yes, sir.
Oh, good. All right.
Yes, sir.
Awesome. Now, after version control, what's the next thing? Where does the pipe go? It comes here, right? This is the next place. So this is version control. Version control system. Let me take VCS, version control system. So after that, the next place is here. What happens here?
So
First of all,
That is where we build on to make the artifacts.
correct, you're right. Alongside that, there is a tool. There is a tool that we are going to learn, like we learned Linux. We are going to learn the commands about how do we pull code from here. When the codes get here, how do we build? What command do we enter to build? How do we save the codes that are available centrally here? How do we build them locally here? So in addition to the central repository, otherwise called remote repository, we also want to have a local repository. A local repository. So we want to make a copy, like we are going to do all the time with our project. We'll connect to the repo and make a copy of the codes, the latest codes in the repo, and put a copy on our system. Now that we have a copy on our system, we no longer need to be going to the repo all of the time. We now have a copy of the codes on our system that we can build and come out with artifacts. So that tool that we use to be manipulating, we're not actually writing codes, we are just, what's the word? That we used to work on the codes in terms of, okay, create a directory, move the codes into that directory. Now build the codes. Now, after you have built the codes, take a copy. You know, it's very similar to, as a matter of fact, it is Linux, but it's just that it's a different tool. That tool is called JIT. We are going to learn the use of the tool JIT to communicate with the central repo, work on our local repo, and then use JIT to tell other tools what to do. All right. So that JIT, let us still consider it as part of version control. So let us extend our version control to, let's put JIT here and extend our version control to it. All right, guys, let's see. You need me to talk like this, I'll be tired in 2 hours. So let's see what we have done so far. All right, so who can give me, or who can just give us the understanding of what happens at this start stage of building an application and deploy that application to cloud infrastructure? Who can tell us what happens here? Remember to use the keywords. Anybody?
We have central repository where the developers where the developers actually work with the codes, and after then the DevOps engineer pull the codes from central repository to the working directory, build the code. After building the code, it
okay,
becomes...
yes, you are past that level. Yeah, I just wanted you to focus on it. Yeah, good at it. All right, any other perspective to what happens here within this area?
Yeah.
First of all, what is this area called?
The area is called the version control system.
It's called a repository.
Hold on. This particular storage that houses the codes that we're talking about here, what's it called?
Central repository.
Repository, central
repo,
Yeah,
central repo. You are correct. You are both correct. It's the same thing. Central repo. All right. So this whole area is not called central repo. It's just this storage.
It's called
that is called central repo. And then what is the general function of your central repo?
Version control.
Version controlling. All right. So the people that did not understand me, you are now understanding. Your colleagues are now. All right. So the role, the job of the central repo is to version control your
codes.
Your codes, correct. Version control your codes. Beautiful. All right. So who can take it from there now? So,
okay. Then there is a software called JIT that helps the DevOps to pull code. Is a tool here to pull code from the remote or the central repo to a local repo where the code is built into fact.
correct. Awesome. Beautiful. Beautiful. All right. Who else can try? And then from a different perspective from what these guys have not mentioned. In other words, I have this idea that I want to set up. I want to build an application that would give everybody $1,000 every month, free of charge. What's the first thing that I do from your understanding of this?
Yeah, the developer.
This thing we're discussing now is called it's always called the architecture, the overview. All right, go on. Yes.
Yeah, we have developer from different continents and different places.
So the first thing we do is we hire developers. Is that what you're saying?
Yes.
Correct.
From different countries. They work per time per session. After doing their code, they put it on the repo for other people to start, or probably where they end, other people start from there. So we have enough code at the repo. That's the VCLs area.
Yeah.
So we then use the tools called the Git, which enable us to pull the codes and the design that they've already worked on to pull it to our local repo, where we can now build the artifact from there on. The process started from that place.
Correct. Beautiful. This is called code, not let us stick with the word code, not design anything. Beautiful. Now, I want to draw a question from that. We have developers. This concept of developers, well, assumably in different countries, working together and pushing their jobs individually to a version control system. What is that concept called in IT?
Is it collaboration?
Collaboration. Correct. Use these words and you get it.
Akin, can I ask a question?
Yes,
so with what the developers are doing, is it like an open source?
No, they are writing codes. They learned programming languages like Java, Python, Node.js, PHP. So whatever language they are writing, they are called SDKs. They are writing codes in. They are programming. Okay. That's what they are doing. They are writing programs. Did you get that?
Yes.
Okay.
Yes.
Not really. Okay. So this is what happened. Let me explain that further. So I have this idea that I'm a businessman. I have like $3 million and I want to invest in this business of developing an application. All right. That hopefully I make money from, or maybe even if I don't make money, I'm just satisfied solving some word problem by that application. So as a businessman, I'm not a techie, not a tech person. I don't know how to go about it. So the first thing I do is I hire somebody who understands business on one hand and also understands, let me write all this. I didn't want to, unfortunately I have to let this go. I didn't want to.
Another page.
Okay, another page, right? I didn't even think of that. Okay, good. All right, so how do I do it? Okay, I'll zoom, right? And then I do this. Awesome, thank you for that. Okay, so this is the businessman. That's my pen. How do I draw somebody? Something like that, right? I'm the businessman and I want to develop an application. I know that this is possible with software. I need people to help me write codes. I'm not even aware that after they write codes, they need to convert to, I don't even know. So since I only have the idea, I don't know how to write codes. I don't even know how. So I will employ somebody, I'll get somebody. I'll get a different person here. This kind of old model, though. This not really work like that, but just to give you an idea. So this person will be between me, tech, between business and tech people. So he will take my high-level requirements. It's called high-level requirement. In other words, he will understand what I want to achieve in plain English. You take the business objective, interview me, find out what I need, and then he will translate that to low-level requirements, low-level requirements, otherwise called detailed requirements. It is these detailed requirements that the programmers would use, will understand. He will come up with a document from that low-level requirement or detailed requirement that is called requirement analysis. I do not intend to go into detail, but I just wanted to bring out how these programmers knew what to program. So this person here that is in between me, that will come to my office regularly, and even apart from me, also interview other stakeholders, even prospective customers that will use the application, and so many other stakeholders apart from me. This person is called business analyst. So he's able to extract from this interview what needs to be done, and he writes them in a language that is not plain English, but like pseudo program. So this is the document, the requirement document that he now prepares. There'll be folders, big folders of requirement document that he will now hand over to the tech department to say, this is what should be coded. So this is where these people are. It will write line 1. Line 1 says, when a customer buys, he should be able to cancel. How do I convert that? These people will not convert it to code and say, for a customer to buy and be able to cancel, I'm going to say A equals B, B equals C, and then they write that in Java. Do you get where the code thing came from now?
Yes.
And then after they have written in Java,
can you come again, Mr. Akin, please?
From what point?
From the HLR to the
so
lawyer.
Me as a business person, as somebody who has 3 million naira and $3 million, right? For me, that's a big man, right? That's what I wish to have. So I'm not a tech person. I cannot come to Mr. Aregbesola class and be learning programming, how to convert. I'm too big for that. All right. So what I'll do is I'll hire somebody who would come to my office and get all of the ideas that I have in my head and convert that idea to a document that programmers can understand. That document is called requirement analysis doc. It is this requirement analysis. It's not just one paper. It's like, depending on how big the application is, we can come out with 10 folders of paper, each folder filled with papers, each paper containing requirement document, different formats, in form. So this is where the programmer knows what to program. They are not just working from their head. They are looking at documents to say, the application we are developing must be able to do 1. So they will convert this statement of the application should be able to accept Naira. They'll write that in code. What is the code version of? They should be able to convert Naira. So it means that in Java, they are going to say A equals number. Append the sign Naira to the number. And then you write a code, I'll put a box somewhere. So, and then customize this box, not in graphical form, so in code, so that this box will not accept string, will not accept anything other than number. And when it accepts number, that kind of thing. So they convert that line to code. And then just like they did for that, they convert the second line to code, convert the third line to code. By the end of the day, they would have converted like 75 lines of requirements here to code. This is the code that they now push to repo. to say, I have done my work. Remember, this is 10 files of documents. So the work continues the next day, the next day, the next day, and so on and so forth. But the point I'm just bringing out from here is that these codes that are being written originated from, are not coming from the blues or coming from no, they are
on the big board
in document form. They're in document form as analyzed by the business analyst and as he was able to draw from the business, the idea owner, the other stakeholders, such as the subject matter experts, such as the customers, such as a sample of one or two people that would ultimately use the application, and about 7 different categories of people. You will interview all of them just to make sure that it gets the requirement right. So that is where the coding part, this coding that we're talking about, that is where they got the idea of what are they coding to push. All right. Okay, I think you did justice to this part. So you said for this project, the first thing we have to do is hire developers and then set up our central repo and then ensure that they all have account in the central repo so that they can access the central repo and be able to push and pull codes from the central repo. All right. Awesome. So, and then the next thing would be, yeah.
Sorry. So my question is, who create the central repo? Or the developer
anybody can do it. You are going to learn it today. It's very, very simple. Yeah, anybody can do it. The simplest of things. So
yes,
today
on the second page, on the second page, please. You were, after the code is written, you were continuing. Yes, after the A equals B, B equals C, you were going somewhere there.
After so after the code is written, this is the code that we're talking about here that they now push. This is the code we are talking that they now push to the central repo. Each person will write codes and push to the central repo. So everybody will have access to this document.
Sorry, quick question. Yes, you're talking about business analysts and the big man meets the business analyst and the business analyst meets the programmer. There's something amidst that place that I need more light. Where is the place of a program analyst before the developers?
No, those things are not rigid. It doesn't mean that on a project you must have project manager, business analyst, program analyst. They are not rigid. They are just guide.
Okay, thank you so much. That's what I want to know. Thank you.
Yeah. In any case, if you do need a program analyst, the same business analyst can act as a project manager and a business analyst. And also, these days when they are hiring, they want one person who can do everything. So you don't necessarily, you can wear 3 hats. You can wear the hat of program analyst and all.
Thank you so much. I understand.
All right. Welcome.
A DevOps engineer can also be a developer, like the code.
They will love you. They will love the same person to be, but maybe 15 years down the line after you have become a DevOps engineer. Yeah.
From my experience, I think most people before this thing now came to being, they normally use developers to do all these jobs. Yeah. But when the thing is getting bigger, especially when everything is moving to the cloud, then that's why the need for DevOps now erupts. And it's a very, very big something for anybody that has gone through the application process. This is not the stage that they give to developer. You must be a developer and understand every aspect of the code before they can give you this role. It's a senior role. Even to now, it's still a senior role. As a DevOps that I know, the place where I work, DevOps is like a big boss to all developers because indirectly you report to them. Because when you write code as a developer, you put it into your GitHub, whatever, or a special repository that the company asks you to do it. They already give you a link. So you and that's where the DevOps engineer will take it and now started building the code. So DevOps are the boss. They are the boss of developers. They don't just give it to anybody. You must have understand your tools very well.
Yeah.
Because your job is a very high job. It's not a small job.
Yeah, I agree with you. That's a good explanation. And by the way, the person who has the question, remember that you as a DevOps engineer, you have been through this. Can you see my notes? You've been through this. You've been through this. Now you are going through all of these tools that we are going to learn. Do you think you can really combine development with all of this workload? And there's still more to learn. We're not even talking about cloud-specific DevOps. We're not talking about Kubernetes alone. So, man, it'll be so much work if you want to be both. You want to wear both. So, yeah, I agree with Yomi or there in this approach. All right, but you're already a developer and you feel like, you know what, let me also go and enjoy what DevOps people enjoy. Because development is more tasking, then it's easy for you.
Like the man's talking.
Yeah, okay, he's a big boy, right?
I'm not there yet. I'm just trying.
Yeah. Awesome. Okay. So good to have you participate. Now, okay. Yeah, so we understood, we have all understood to the point of building artifacts from there. All right, let's go back to the note now. All right, so we now know what continuous build is, or did we explain that? Actually, as long as there is continuous version control, as long as the codes are changing, we may need to mute somebody. As long as the codes are changing, then there is also need for you to make new builds out of the constantly changing codes. So that's why, as long as this one is changing, that's why this one must change. Every time there is a change in code, there must be a new build, a new artifact must come out. All right. So there are different tools for building, building your codes. We have Ant, we have Credo, we have Python Builder, we have MS Builder for Microsoft. But the one we'll be using, because we are building Java projects, and the one we're going to learn, again, very simple. The explanations of these things are more difficult than the implementation. It's Maven. So we're going to use Maven to build our codes and then to continuously build code every time there is a change in code. All right? So this is how the whole thing is going to flow. This one should have come first. Why? Let me put this on first. Control X. All right. So the plan is the first stage. First of all, this, you know what this sign means? It means infinity. It never stops. This concept never, this development releasing to it never stops. So it starts with plan. I have a dream. Oh, if I build this application, I'm the business owner, right? And then the stage of calling the business analyst, it doesn't, I don't really have to, but I'll just use that. I just use that as an explanation. All right. So I document my plan. Maybe I put it PowerPoint or in Microsoft Word or MS Office, whatever. And then from there, we jump this other part of calling business analyst. We go into code. My plans are coded. I know that in reality, there has to be some requirement gathering and requirement analysis and analysis document. Yes. But the next stage, as far as DevOps is concerned, is we convert my plan to codes. And then after the codes, what do? They push all of the codes to repository, and the DevOps engineer pull the code from there and build the codes into artifact. And then he tests the code that was what I meant by he puts it in a container. He tests the code here. Again, in reality, it doesn't have to be 3. 1 is okay just to test, but I'm just saying this is the place of, this is just a theoretical model. All right. So he pushes the code to an environment where It is tested or not necessarily so. And then he tests the code. But again, don't worry, I will explain this kind of test. This test is different from that. Once it is concluded that this code, this artifact, this app is good enough, then it is released. Released to where? Remember this diagram? Look at this. It is released to where? Your cloud infrastructure. And we say that this part is development and this part is operation. So where is it released to?
Production.
It's released to operation. Yeah. All right. Correct. All right. So that process of release, you say you are deploying. You deploy to production. All right. Once it is deployed to production, it means that it's in operation. In operation means that the whole world can access. I mean, when I say the whole world, whoever you built it for can now access it. It's now in your, if it's a web page, it's now in your HTTPD server with a public IP address that can be accessed globally. And then ideally, you expect that, finally I'm done, the work stops there. No, the work does not stop there. This application must be monitored constantly using monitoring tools so that the feedback from that monitoring cannot be used to replan. Oh, we forgot to add $sign. Oh, we didn't expect that 2 million people will be online at the same time. Our resources are not working optimally. Oh, customers are now asking for a shirt every time they buy a pair of trousers. We need to, there would always constantly be need for changes. We want to call those changes improvements or feedback. So it is the monitor that will capture how this application is behaving in operation, and then to give you room for, oh, I need to do this. That needing to do this means that you come back to planning, convert to codes, build your code, test your code. Your code is good, release to operation, and then deploy. Operations is in the market. Market people are using it, and all of a sudden 1 million people are saying, we want this particular service. You come back here again, and so on and so forth. Infinity, just this thing. So this part of the program, this part of the entire pipeline is called CI, continuous integration. And this other part is called CD, continuous deployment. All right. So we are going to automate. At the end of this whole place, we are going to
we should have. Are you still within this infinity sign?
Yeah, I'm still here. Are you saying?
Okay, all right, sir.
Yeah, I'm still there.
Okay, all right, sir.
But did you understand this explanation?
Yes, I did, but I think I wasn't for the operate after the deployment, before the monitor.
Yeah, operate is when it is live in your cloud server and the whole world can access it.
Okay, sir. Okay.
Yeah.
All right, sir.
Yeah, and then you keep monitoring. You plant tools. All of this is about tools. Tools there that'll be monitoring the operations and giving you feedback about they are using 95% of your server CPU, and then oh, it's time to go to a higher kind of EC2, for example. Or customers are always 98% of your customers are browsing a particular page. So it just gives you all those kind of feedback that will now help you improve, plan all over, and improve on your. All right. So that's questions.
So, sir.
Yeah.
So in that case, when you want to do those improvements, are you going to redo another one again and go through the same process? Like you just said it's already there, or you just update the one you have there, or you
do
that one and put a new one?
Do you see this sign?
Yes, sir.
So it means that you go all over to plan. So you plan again, you decide how do you technically achieve the requirements gathered by this monitoring tool. And then you give to your coders. Write that out in requirement document, give to your coders. Your coders would would change the existing code to reflect these changes that you have asked. And then you build a new artifact. So what's your question? So whatever you are doing, you are not killing the whole thing. You are not starting all over. You are improving on existing.
Okay, that's what I want to ask. But I want to ask, like, maybe you're just missing a dollar, like a sign. Are you going to kill that one and go to another and put another sign and bring it back again? That's what I'm just trying to clarify.
Yeah, you are improving on what you have. It's continuous. Another word for this is continuous improvement. Always.
All you just got to do is just send those improvements to it and it automatically takes effect.
Don't worry, we'll do. Just get the big picture now. We have how many documents? 52-page document. By the time we are done with the 52-page DevOps1, and we'll do another 52-page DevOps2. All of these questions will answer them. But for now, just note that there are 8 stages: 1, 2, 3, 4, 5, 6, 7, 8 of a typical DevOps lifecycle. All right. So let's ask questions now. Now, we have seen that DevOps engineering is basically about automating the process that we just described here. It's about automation. What about DevOps itself? DevOps is not, yes, all of these things we are talking about here, they are DevOps tools, but that's not DevOps. DevOps, you'll be surprised to know, is not a technical term. It's just a concept. It's just the culture of continuous improvement. That's what it means. It's just the concept of continuous improvement, continuously improving on your code so that Facebook application is not the same as it was 3 years ago. Between 3 years ago and now, there have been a lot of changes. And in another 2 years, Google application will not be what it is. It's always continuous. The tools that you employ to bring about that continuous improvement is really up to you. However, the industry recognized tools for achieving these goals optimally are the ones that we have highlighted here and that we'll be using to deploy, to achieve the concept of continuous improvement on our application. All right, so we stopped here. We stopped at building. Before I continue to Jenkins, integration and all of that, let's see if we can answer a few questions. Okay, so let's go back to. All right, so what is DevOps? What do DevOps engineers do? Yeah, first of all, what do DevOps engineers do? Let's see the best answer.
DevOps engineers are in charge of automating the system, the go-getter between the development team and the operations team.
What exactly do you mean by between development team and operations?
The developers, we're looking at the coders.
Okay.
And then the operations side, that is where we have the production, the production line when it goes live. So you're collaborating between you're the go-getter between the development and operations. So.
Okay, I understand that, but okay, you've tried, that's good. Who can
Can I read it from my note?
No, not from your note. I'm testing your understanding, not from Google, not from.
No, not necessarily from Google. I'm just writing note down. That's what I mean.
No, I prefer to hear it without you reading it.
Yeah.
What do DevOps engineers do? We still have this in front of us.
Yeah, DevOps engineer are the people like taking all the software from all the Java, trying to make one application to go through the local. We got it. Yeah, the one that like having. I'm just trying to put everything the way you just said it.
Mm-hmm.
Like now, they were the people like getting all those software, the coding from the repo, then use your tools to work, the Git tools to get to the local repo. Then from there, I started like trying to get information from all the sources from different countries, from that is software, from the Java. Let me just say from the Java. Then
okay, don't worry. Not quite there yet. Don't worry. We'll get it clearer. But who can help us from this picture here? What do DevOps engineers?
Let me give it a shot. I'll say a DevOps engineer is like he's a bridge between the development team and the operations team.
I don't know what development team is, so you're assuming that I know. So I need to know what the DevOps engineer.
The DevOps engineer is the guy that collaborates, that move the codes, that deploy the codes, the apps to come to life. What the apps really want to do. Is the guy
exactly what the first speaker said, but I want a different perspective. That's correct.
So I'll say the DevOps engineer pull codes from the repo and with Gig take it to the local to get it, then let it go through the testing before it goes straight to the cloud and monitor it or maintain it in the cloud.
Yeah, fair try considering that you are hearing this for the first time. Good. But
again, as the guy that is the DevOps engineer is the man that works with different tools to deploy the code to the production stage.
Awesome, beautiful, but not. I still have not had everything I want. Almost all of the tries are good answers.
So the DevOps engineer is the person who moves the codes from the coding part of it to testing, quality assurance, all the way to the production, and pretty much take it live.
Okay, good. But I have not given any of you full mark.
From what I understand, excuse me, pretty much a DevOps engineer is pretty much the person that helps with the development of the code in terms of they figure out if the code is good, if it's not good, and then
no, that's not called development. They don't develop code.
I mean, in terms of like they pull the code from the repo, right?
Okay, so they build codes.
They build the code from the repo, and then they use automation to make sure that the code is good. And then when
they use automation to do what?
They use like tools to make sure that the code is good. Like I believe it was Ansible and stuff like that. No, Ansible is to build, but there was.
You are going outside class. I've lost you completely. I became interested when you mentioned automation, but.
Okay. Let me try.
So the word that I was looking for, the reason I did not accept any of the previous, well, they were good.
Is it collaboration you are looking for, sir?
Let me try, sir.
I accepted almost all of those.
I also want to try, but I don't.
Let me try, sir.
Let's try, yeah. Because I've already. I'm afraid that somebody. Okay.
Yeah, DevOps engineers pull codes from the repo, and they work on it using the tools, the different tools, to ensure that those codes to show a continuous delivery of those.
All right, another good try.
Yeah.
So any other person?
Okay. The word you're looking for is continuous. They continuously build and deliver applications.
Yeah, that sounds good. I mean, yeah, well used, but not quite the word I'm still looking for. But there's no way all of your definitions, explanations are correct. There is no way it will be fully correct without a mention of a particular word.
Automation.
So there's a key word you are looking for.
Yeah, look at it here. We saw it together. Look at it. Is it not bold on your screen? So just look for a place to add automation in your definition, and then you are good. Automation. It's about automation. Yeah, I know you will say, from my explanation, you should have known that I was talking about automation. Yes, but I need to hear this word automation. So what are they automating?
I said the word, sir.
Yeah, the person who said the word did not
It was
Yeah, you
going
tried,
in
but
default.
you did not fit in the pipes properly for it to land well. All right, so what are they automating? They are automating they are automating this process, which you all said well. This process from this start to this finish. So somebody was saying the process of pulling codes, building them, running them through the CI pipeline, and to ultimately deploy in production. Yes. Another person said integrating this continuous integration of the development with the continuous deployment of operations. Yes, all of that was correct. I just needed you to add and then automate the, if you do all of that manually, then you are not a DevOps engineer. Automate that process. All right. All right. Beautiful. And then what is DevOps? DevOps engineer is different from DevOps. What is DevOps? And what tool will a DevOps engineer use to build Java codes?
They use the GitHub.
GitHub.
Wrong.
No, they're not using GitHub. They're going to use Maven.
Sorry,
Maven. They use Maven.
Yeah.
Maven is a kind of a application that you can use in VS Code.
It's right here. Can you see my screen? The answer is right there.
Yeah,
so Maven is a tool. Everything we're discussing is
yes, so
a build tool. It's a build tool. So it's
Okay,
Maven.
what about, you said GitHub is a tool between, can you go back to your
GitHub is a repository.
It's just a repository. It's just a cloud base where you pull your code. All developers, like he said it several times today, that all developers they submit their codes to the repository, and the repository that they submit their code to is GitHub. And from there, that's why you as a DevOps engineer, like he said, you're going to pull your code from repository, and you start your automation by taking it to Maven and build your code, and that's when automation starts. And you start continue till you get to the last stage. I think that's what he's trying to tell.
Awesome. All right, so now we know that to build our codes, we use a tool called Maven to pull our codes and manage our codes and then ultimately issue the command that builds it within our local repository. We need Git. As for our central repository, where we pull it from, we could use Bitbucket, GitLab, S3, but in our case, we are using GitLab.
So to get this,
yeah,
bring it back.
Okay.
My last brother said the repository is Git. From what I understand,
there are many repositories. Let me just correct it here so that you can. Okay. So these are repositories. Repos. So the repositories are GitHub. Tools for repositories are GitHub, Bitbucket. We mentioned many tools, and then we take only one of them to go into details. And then in our own case, we are using GitHub. We've explained the place of Git many times, and it's still here. And you guys have used Git too. So this it's not the repository. It's a tool for creating local rep and managing your repositories. But the storage, the actual repository will be one of those other 5.
Okay. Yeah.
All right. Now let's continue. Continuous integration. You may not really understand this, but let's just run through them. Continuous integration. That is where you actually add all of the pieces of tools that would ultimately result in your automation. This is the center man that helps you integrate all of them, right? So this is the man that we call Maven. I say, Maven, it's time to build, go and build. This is the man that we call GitHub. GitHub, what do you have? Push them to me. I want to give them to Maven to build. This is the man that we call Java. This is the man that we call Git. This is the man that we call Docker. It is from here that you coordinate all of your work. In fact, let us see the diagram. Can you see that in the middle? And you see Jenkins in the middle, is the integrator, is the coordinator. So for your planning, of course, what do you need to plan? You need your Microsoft Word, Microsoft, anything, CorelDRAW, whatever it is you can use to present the idea you have in your head. So human being is good enough for planning. So typically, interviews will expect you to say MS Office with all of the packages inside anything. All right. What about to code? To code with it's not really. I had my wife change something. To code would. What do we need to code here? The code we just leave that to developers. So for our project, we're using Java projects. And then once the code is ready and want to build, there are different tools for building. But we have deliberately picked the most popular of them all. That is Maven. For testing, there are different tools for testing, Selenium and JUnit. This is where software testers work. But we are going to leave that to Maven to do. And then I'll show you how that is done. When you are ready to deploy, you can deploy to a whole virtual machine, but you are bigger than virtual. Why do you want to use a whole VM to deploy just a tiny application? So you are going to learn how to create containers, hundreds of containers inside a single virtual machine, and then you can now deploy your application to a single container. For operations, we'll be deploying to, here. This thing is, I'm going to remain. To deploy, where's Kubernetes here? We will deploy to Kubernetes. This is old school. I'm going to remember. I'm going to change this to something. And then, of course, we'll use this. And then for monitoring, this is really old school. We are not monitoring with Nagios, Flock, and all of these network monitoring tools. We are going to monitor with container monitoring tools. We are 2023 engineers, not 1994 engineers. All right, so we'll be using tools called Prometheus and Grafana for our monitoring tools. Right, so this is not so good. All right. So that was just an overview of the different stages of the CI/CD pipeline we'll be building and the different tools that we'll be using at each of those stages. All right. The implementation, I assure you, is not so difficult. It's not even difficult at all. All right. It's going to be really, really easy. But the names are big, the tools are many, they may appear scary, but no. No, this one, Groovy codes, no, it will be continuous deployment using declarative pipeline. Yeah, questions at this stage.
Okay, Mr. Aregbesola, are we going to be using SonarQube at any point?
No, we're no longer using SonarQube. Yes. We're no longer using SonarQube. SonarQube is old-fashioned. I mean,
is there any tube replacing?
Yes, Marvin will now do the work of code analysis.
Okay.
And the programming mistake detector, PMD.
Wow.
Yes.
So Maven is now kind of a whole package that is doing the job of also testing.
Yes, it's always
managing codes.
It's always been. So we'll see them. We'll see it in action now. We don't need to go far. We didn't know about it, so but now that we know, we're throwing away old things. All right. So Maven will now do 5 things. It will not just build anymore. It's now also going to do 5 different things. And the 5 things it will do, you'll be surprised. Don't worry, we'll see them one by one.
That would be interesting.
Yes. Next question. Were you scared of SonarQube, by the way? Yeah, SonarQube is kind of, it wasn't worth all of the trouble of configuring it and going through it. When Maven will just do it automatic, easily, and even give you a beautiful report of what was detected. We'll give it to you, even better than, look at it. So Maven will compile It will do code review for you. It will even test your code. It will do your code coverage, and then ultimately it will package for you and give you your Artifactory.
Wow.
Look at it. So it will do your unit testing.
Oh, maybe can do unit tests
of course.
every code.
Look at it.
So
Using a plugin called Surefire.
Oh, we have a plugin then.
Oh yeah, all of these are plugins. All of them. They are amazing plugins. All right, let's go back to class before we lose everybody. So, yeah, we are copying so far. Even though some people, I hope the people that are not talking they are following quietly. All right.
Yes, sir. Where would you? Yes, sir.
Okay. Let's take a step further.
Yeah, we
now,
are with you.
Oh, great. Nice to know. Now, let's talk about DevOps. Before we leave DevOps, introduction, let me just compare DevOps as a new technology to older technologies, so that we know the place of DevOps. All right, so let's go back to Android, please. Okay, so let's move there. So when we're developing software, again, there are concepts, methodologies, procedures that we normally follow. The old school procedure used to be called waterfall model. And what is this procedure of software development? Software development life cycle. It simply means that in those days, if you wanted to develop a software, you will complete the whole software before you release it to the market. That's just what it means. Nobody's going to ask you the details about, right? You complete it. But after this, of course, it has its own disadvantage. How would you complete a $1 million project in 3 years when new especially these days when new technologies are coming out almost on a 6-monthly basis? It doesn't make sense anymore. So this can be the background, but on the foreground, what you really want is, I don't know what will happen tomorrow. I don't know what will happen in 3 years. I don't know what my competitors what technology they would have introduced. So what I want to do now is start my 5G project, for example. Well, maybe that's not a good example. Just run my whole project in iterations. So I want to develop this part of the software that will do something basic, release it to the market. And once that is in the market, I'll use the feedback from my monitoring tool, from my customers, to build the next stage and then release it to the market. And then once that is in the market, I'll look for, just like releasing movies in series, instead of waiting every 2 weeks, instead of waiting to complete the whole movie that will take 3 years to complete. So this will be 2 weeks, what the Scrum Master will call sprints. All right, so this method of this model of software development compared to this model of software development is called Agile. Oh, the customers like it. Everybody is happy. Well, oh, beautiful. Now the next thing we want, everybody come, let's meet. The next thing we want to do now in the project is we want this. We want this. Programmers, did you get it? Do you understand what we're trying to do? Yes. Okay, everybody get to work. Let's go and do it. And then they come up with a new project, the new software. Of course, this one would have gone through what we described here earlier. You will write the code, you will do this, you will build the artifact, you will release to production, it will be in operations, we will monitor, and then we'll now confirm, yes, this is good. And then we'll go to the next one. So we are building the software in iterations. Do you get it?
Yes.
So these are different methods of developing software. This is definitely old school. But no matter how old school it is, we are not saying it's completely useless, but it's not in the foreground anymore. It's somewhere in the background. So waterfall model of developing software, in other words, it means make sure the software is developed, tested, fully ready before it is released to the market. And once released to the market, it's already ready. So you cannot really change anything because it's rigid. It's like building the whole car as one piece. And then once your car goes bad, you throw away the car. But this one is like building the whole car in pieces. or building the whole engine in pieces. You have the radiator, you have what's replacing carburetor now, your injector, you have all of the pieces of the engine, all of them working in iteration, but everything working together as engine. So you can remove this part and replace it, and you still have your complete engine. That is this model. Unlike this one, the whole engine is one piece. So once it's bad, you throw it away, because there's no piece to say, let me isolate this part and replace it. No. Or a common example would be, I mean, something you can relate to it, would be you want to build a house that you want to move in, right? So what you want to do, what we normally do in house building is waterfall model. So we build a house, put all of the rooms, roof everything, and then make sure everything is complete, and then we move in. That is waterfall. You completed the project completely before you move in. But you could, why, if you decided, you know what, I'm not going to build my house like that. I'm one man now. I just need in that house in my mind, what I just need for now is one room. So you build one room, and then you live in the one room. Oh, you're enjoying the one room, your salary is still regular, everything is fine. You add another room. And then, oh, that is fine. And then you just keep expanding. So that after 3 years, the room that had no windows originally now has windows, everything is beautiful, you now have a garden. You built the house in iterations, in modules. So this is agile. You build as you go, but this is waterfall. You have to complete everything before you move. You see the difference?
Yes, I get this.
Yes, I saw the difference. But in waterfall, there is a maintenance. I'm thinking that maintenance also also thinking about also building a modus, or because you said it's rigid.
Yeah, maintenance is not exactly the same. Yeah.
Okay, because what I understand by that waterfall is requirement, design, implementation, verification, and maintenance. Then
yes,
I with that maintenance is where people now be adding modules like that of agile that you discussed now. I just want to
waterfall is different from agile projects. So maintenance is not the same thing as all of this.
Oh,
can you see my screen? It's not the same thing.
Yes. Thank you.
But in agile, you need to go through planning. In fact, you are coming all the way here again in agile. So for every module, for every iteration, you'd go through this whole process.
Yes.
So that's why we said it's continuous. It never stops. So even if you have the best software, the best application in the whole world today, it will not just stop because you have the best application. You will still continue to plan and improve on it. And that means you are repeating all of this process for every module.
Yes. Thank you.
The waterfall is not there. All right. And then your place here is deployment. Okay. So that's the difference between waterfall and agile. But what you should really know is agile, because you'll be working with agile teams. But what is agile? What do we mean by agility as it relates to DevOps? This agility that we just described here is only, did everybody understand that first part? I heard somebody say, yeah, with with this analysis, they now understood it, right?
Yeah, I understood it better with the second analysis, with the single rooms build.
Okay, that's fine. All right. Now, this part, this agility has to do only with the software development, the application. I prefer to use application instead of software. Only with the app development. In other words, we are talking about waterfall, we are talking about agile methodologies. We are only relating that only to this part. Can you see my drawing? What other color can I use? Only to this part of the whole project. Only to this part. Because this is the part that has to do with development. So agile methodology, waterfall methodology is not saying anything at all about operations. It's fully focused, concerned about software development, application development. So you now see that if we say that the development part of the project adopts agile, is that a different term? If we now say that it adopts agile methodology, then it stops here. Your agility stops here. What about here? So it is the DevOps engineer that is able to interface this agility with operation. So that's why they normally would say in job description that you'll be working, that you should know about agile methodology, basically because you'll be working with agile teams. These are agile teams. The job is always there. Every 2 weeks there for this agile team. So on one hand, you are part of the agile team, so you'll be familiar with what they do. The manager of the agile team here is the Scrum Master, all right? He is certified, he knows how, again, it's methodology, it's a concept. So it's a way of life, it's a culture, you know what I mean? It's something that whatever you have to do technically must be superimposed on that culture in order to guarantee continuous improvement. Other methodologies that work like that would be Sigma, Lean, and they have so many other not technologies, methodologies that will help you conserve waste and maximize your production. But the point I'm making is that all of that affects only the software development part. It is only DevOps that integrates that agility with operation. So that this wall that I put here now, it is the DevOps person that eliminates this wall. There's no barrier anymore between the, development and operation. So instead of the development people developing an application or modifying an application, deploying it to production, and production saying, it's not working, something is wrong. That demarcation, that separation is no longer there because this wall has been removed by the automation that the DevOps guy has made possible. So things will just flow from this department to this department without them even knowing that they are separate departments. All right, questions?
So, Mr. Akin, pardon my ignorance. Can you go back to that infinite symbol again? So does it mean that the infinite symbol of DevOps?
Okay.
So does it mean that looking at the black and the green, so the left side is also expected of a DevOps engineer, you know, some required skills to know?
Yeah, everything here is the work of DevOps engineer. It requires
including the black. Okay, I was thinking it's the development aspect for. Okay, all right.
No, so the black part represents the continuous integration part. The DevOps engineer has to set it up from.
Oh, okay.
Yeah.
All right, because going back to your chalkboard, and the explanation you just made, I was trying to think that in my head. Thank you.
Okay, you're welcome. Yeah, good question. And do you know that some interviews could be so simple that it is just your understanding of this DevOps concept that they need? Yeah, I've had interviews that are so simple. They may ask you questions about what tools have you used to do this, but it will mainly be about, do you really understand this DevOps culture? Do you really understand what it means? So it is deliberate that you are spending 2 hours just to understand the concept and know what DevOps engineers, not just what DevOps engineers do, but the architecture of this whole DevOps concept, especially as it relates with agile methodology or software development. So it's good that you're asking questions and you are getting clarification.
Yes, sir. Thank you so much. I've always imagined how to integrate agile methodologies into DevOps, because just last month I got certified as a Scrum Master.
Wow.
So I didn't even know, I mean, agile would be very useful in DevOps. So, because I've just been thinking about it, really never went into research or any white paper on that, but I'm glad the way you are integrating DevOps, agile into DevOps. I'm very much
You're welcome.
appreciate it. Thank you, sir.
Yeah. And your note also has it. So agile is just the development stage only. All right.
Okay, great. Thank you, sir.
Yeah. And then I'll share. Come on. I'm not sure I'm sharing notes yet, but many of you have not paid for the course, but we just allowed you to come into this course so that. But for the people who have paid, we'll share notes, and then the videos will be made available to people who have. All right. So that is also captured in your notes. That's good. All right. So let's interact now. Let's interact. This is not so different because the concept of understanding, because like I said, understanding the concept is very important. That's why I have deliberately put so many diagrams there just to make sure that you understand what you are doing. Because at the preliminary stage of the interview, in fact, at the screening stage, when the recruiter calls you to say, we saw your resume, we think you might be a good fit for this role, can you give me a high-level overview of what you do? These are the diagrams that you'll be explaining. That's why we have many of them. Many of them. Right? Understanding these diagrams and being able to know the difference between continuous deployment and continuous delivery and so on, that is what gives you the first interview, the screening interview. And then after that one, they will now be asking you questions specifically about what projects do you deploy and how do you deploy it. That's what we'll be taking. We may not really go into that today, but we'll really. All right, let's go on, guys. Or do you need a break? Do you take a few
The
minutes?
class is how many hours?
It's 3 hours.
Okay.
Yes, sir. Let's take
a break, please. All right, so can we take a 13 minutes break? Is it okay? So that we'll come back at 12 minutes break.
Yeah. Yes, sir.
Yes, sir. I'll come back at
7:38. 7:50, right? Oh, yeah.
Okay,
good.
sir.
All right,
Thank
let's
you.
take a break. Thank you.
Oxygen, don't keep flying up. All oxygen. They flying don't wake up. People come, they fresh air. So they wish they wish you. Now then everybody does a course. Now go the video Instagram page. That's it. The whole world love that and so in people they just a post. Show me what this do. Show me what this do. Show me what this do. Yeah, what I'm trying to do. What else? Yeah. You can't wait to see the but once she gets the money, once she gets the last week, I'm not going. Yeah, the take the time and get so good.
Mo fẹ́ lọ. Pẹ̀lú ọ̀gá náà táìmù tẹ́lẹ̀ which day you are not getting time. Kò tó mọ àwọn kékeré bẹ́ẹ̀ lọ. Kò tó mọ àgbélé wálé. Ìyá bá tó fẹ́ lọ.
Mr. Oladok, we can hear your conversation. Please mute your microphone.
All right, guys, welcome back to class.
Yeah, welcome also.
Thank you, sir.
Thank you. All right, let's just do a little more explanation, then we'll go do something practical. All right, so one more time, don't define DevOps without mentioning automation. It's about automation. And there are different companies operate at different levels of how
I'm sweating. Is that sweat? Come here, come here, come here, come here, come here.
So some companies will deploy as frequently as every 30 seconds. Maybe that's a bit of exaggeration, but what we mean is for some companies, the codes, these codes will change. The codes coming from here, they will change as often as every 1 minute. How can you manually integrate codes changing every 1 minute in production if it's not automated? It's not automation that can do it. It's not automation. Especially with the big companies, the funds. They change funds now to something, right? So whether you see, when we see application deployment into production at high velocity, it simply means that big companies like Google, Amazon, Facebook, they integrate their codes change every 30 seconds. And remember, continuous build, everything is continuous in DevOps. So once something changes, it should affect the whole pipeline. That's the meaning of continuous. Once a code changes by one of the 3,000 developers across the world, it should affect the whole pipeline and ultimately result in a change in production. So the website you are seeing in production may not change. You may not see the difference, but somewhere amongst the 3,000 pages on the web application, something has changed. The fact that you did not notice does not mean that something has not changed. All right, so we normally define DevOps as the automation of application deployment in high production environment with high velocity. All right, it's about practice. All right, then one more time, let us look at this. It means that when we're doing version control, if there's any problem, we can always go back and correct that problem. Even after we build, if there's any problem, we can always go back to correct that problem. We cannot carry problem forward. It's forbidden. DevOps does not allow it. If there's any issue, it phase test, it must be such that you can go back to where? To developers. Let the developers fix the error and then push the new code. Because every time they remove a comma where there shouldn't be a comma or add a full stop that they forgot to add, the code has changed. As little as adding space, the code has changed. And once code changes, a new artifact must be built from the new code. Emphasize that, and so on and so forth. And so at every stage, there's always feedback to correct the mistake until it is deployed to production. And after it is deployed to production, it is live. It is too late to make any correction. All right? The only thing you can possibly do then is monitor the application with the use of monitoring tools and then get feedback and use that feedback to plan and indicate all over. To avoid the possible mistake of pushing wrong into production, that was why we introduced the test environment, the QA environment. QA means quality assurance. You just want to test everything and make sure it passes your quality test. The organizations like Facebook and the big tech companies, they have high quality standard. Otherwise, one small boy will just come from behind and overtake them. So they have to have all of this quality control system in place before they are eventually application is eventually pushed into production. Although that is that's not shown here because of the concise nature of the diagram. Okay, we already explained that. And then we also explained yeah, I can't hear you, but I believe you are hearing me. High level overview, you must understand this. Rehearse this over and over and over until you're able to convince your recruiters that you know what continuous development is. It's not going to ask you what's continuous development. You are just going to learn to imbibe these vocabularies in your, these steps in your vocabulary and be able to express yourselves in ways that reflect your knowledge of these steps. Continuous development, continuous testing, continuous deployment, and continuous monitoring. All of them integrated together centrally using a continuous integration tool. All right. As you begin to use the appropriate tools in their respective places, you'll get used to them. For example, for continuous development, we're talking about Git, GitHub. For build and testing, we're talking about Maven. For integration, we're talking about the tool called Jenkins. For deployment, we're talking about the tool called Docker. And ultimately, Kubernetes, which is the biggest and the last cost. Well, not the last cost, monitoring will be the last, but the biggest last cost. For operations, yeah, we go together. When you deploy, whatever you deploy to, that's where you operate from. So they go together. For monitoring, we're going to do Grafana, Prometheus and Grafana. All right, yet another diagram trying to explain to you what code means, what build means, what test means, and that at every stage you must go back to plan to correct this. The part to the left of the test is called continuous integration, and then once it is released into production, it is called, from that point, it is called continuous delivery. From the point where it is released from your test environment to your production environment. So the continuous integration, I will show you how you can do all of that from your laptop. So you don't have to go and spin up. Yeah, you actually already know half of it because you already use a VS Code. So your continuous integration will be done locally on your system. It is only when you're now ready to set up to deploy to production that you now need to go set up your production environment in cloud in order to deploy it. All right? Which is the modern way of doing stuff rather than setting everything up in cloud. All right, guys. So finally, when we say DevOps, it involves everything, like we already said, from planning through coding. Although you're not the owner of the idea, but it's still part of it. Planning, coding, you are one way or the other part of. You may not be the coder, but with your setup of GitHub and using G to pull and push and all of that, you are part of coding. And then you build, you are part of all of it. So another way of representing that linearly is through this diagram. DevOps involves everything from planning to deployment to operation. All right. But when you plan and you deploy without actually operating, we call that continuous deployment. When you plan, you code, you create, you test, you release to operation. At that level, we call it continuous delivery. All right. At the level where you only test, we've said that many times, is continuous integration. But when you do not test, all you do is build code and create you build code and then no, you don't build code, you build artifacts. What's the word now? Yeah, you build artifacts from code, that's right. You build codes, yeah. Oh, the first one was right. You build code and the result of your build is artifact. That part is only the software development. You are not doing the test. And that is what we mentioned Agile as the methodology for delivery. All right. And then when you are operating and your feedback from your operations goes all the way to management or to the appropriate team, and then it goes through planning, that is achieved by continuous monitoring. Continuous monitoring is what this is feedback from operations. And then what's this one telling you? This one is just telling you that what we want to do is create a pipeline. If it was a physical structure, this is what it will look like. Create a pipeline that will link all of the different stages and the different steps involved in automation together, so that whatever you push in here will follow this pipe without anybody doing anything automatically to get to that level. And then we'll use all of these things to achieve continuous integration and continuous delivery. All right, we'll have, yeah, you understand this better, right? And then I try to represent, after you build, you can push, instead of pushing to production right away, you want to push to an environment where you can test, you stage it, just make sure, even if it's possible to pass through 7, depending on the kind of company. If it's my company where nobody knows me and nobody wants to see me for anything, and I have to make mistakes. For the kind of company that would employ you and pay you 6-figure, you don't want to make mistakes. So they want to, first of all, ensure that the code is okay by testing within different environments. We call those environments test environments, stage environments, QA environment. Doesn't matter what you call them. But you're basically saying that you want to make sure the program is okay, it's tested. Not you alone, everybody involved. I mean, it's a big team. There are testers, there are, like we mentioned earlier, different auditors, different people from different aspects of IT, networking, security, especially security, governance. You know, everybody wants to test it before. Of course, they have their own way of also automating their test processes. It doesn't have to be manual. And then it passes all of the tests before it's automated in production. Now let's go do practicals, guys. Are you ready? Any question before we start practical? You may unmute yourself, you know.
Yes, sir, we're ready.
Okay. All right. So the first thing we want to do in practicals is to set up, to start from here. We don't have control over our developers, so we're going to set up our own system as the developer would set up his own system. And then we're going to set up the repository and then connect our system to repository with Git, and then go ahead and download some Java codes into our local rep and then start to work my Java code, start the build process. All of that may not be today, but wherever we stop, that is it. All right, let's go. So we're using GitHub, so we're going to go here, and we're going to do this. Then we're going to say GitHub, GitHub. GitHub. Anybody on the assistant?
Yes.
I'll help you say this. If you're your sister, let's do it together.
Okay.
So let's do github.com. And then where am I? All right, so you should see sign out. Actually, it's in the notes. So go to, can you see my notes?
Yes.
All right. So the first thing we want to do is create our background control system using GitHub. So go to github.com. And then sign up. I already have an account. I signed up already. So in your case, you sign up. Click sign up. Complete the form. Enter an email address. Click continue. Yeah, you signed up so many things already. So you're able to complete the sign up. Remember your email address and your password. This is how everyone else would create an own.
So if you have it already, go to my profile, right?
Yeah, if you already have an account, then you sign in instead of sign up.
Okay.
All right. So this is collaboration. How do you collaborate with your team? Of course, number one tool for collaboration is GitHub. It's where you share your code, share your. It's a VCS generally. Collaboration tool is VCS, version control system. If you don't decide to use GitHub for your VCS, it's good. Anybody completed registration yet? I mean, sign up yet? Anyone trying to sign up?
Yes, sir.
Okay, at least someone is trying to sign up. So we'll work with you. Let's know when you are signed up or if you have any issue.
It says create username.
Yes, give a username. My username is theITern. Use your own. Let's see, who do we have in this class? Who do I recognize? Ayodele Fapore. I know you have paid. Gabriel Mary, looks like you have paid. Robodo, looks like you have paid. Moses, I don't think I saw that name in my register. Paid. Olusoji. You have any lady in this class?
Yeah, this is Olusoji, and I was the one that communicated with you on WhatsApp today.
Olusoji, if you know how many people communicated with me, you say, wow.
Yeah, but
It's
you
hard
mentioned
to
my name
remember.
when you mentioned my name.
Oh, Olusoji, yes. I know now.
Thank you.
Yeah. Do you have any lady in the class? Please carry on with your registration. I'm just using this too. With your sign up. Can they speak up?
Giselle said something earlier. Yes, she's at work. I want to believe.
Okay.
Oh,
Giselle,
I'm right here.
What's that name?
Giselle.
Let me see. Say it again, sorry. Oh, Giselle, okay.
Yeah.
Oh, okay.
I should have paid.
Mm-hmm. But what?
No, but.
Okay, we're waiting.
Excuse me, sir. I have a question.
Okay.
It's asking what specific features we're interested in using.
Just pick any one, not really important. Any one or two.
Okay.
Yeah. Okay. All right, so please, let's go. So in my own case, I'll sign in because I already have an account. I have a couple of accounts. This is not the one I'm using. Yeah.
It's asking me to authorize Terraform registry. Authorize Terraform.
Okay, go ahead and authorize. I'm not sure. Either I'll let you pass here. Authorize. And then I think you need to, did you send some confirmation email you need to go verify?
Yeah.
Okay.
I think that should be the last step. Once you insert those codes, you should be able to
when
find.
it's asking of how many team are you going to work with, what are you going to just omit it?
Maybe 1 or 1 to 2. Can say 1 to 4, whatever the other option is. What are the options? Did you say 1 to how many? 1 to 5 or
just me, 2 to 5, 5 to 10, 10 to 20.
Maybe 2 to 5 should do so that I can experiment with others.
They said, are you a student? All
right. Student may not be ideal because it may require your student email address.
Teacher, right? You can say teacher.
Then
Yeah, anything other than student.
If you're a student, what will you do?
May I require your university email address?
Yeah. Okay.
But
Mr. Akin, I didn't know better.
Yeah.
I didn't know better. I chose student and
if it allows
my
you,
personal email.
So it's asking for collaborative coding, automation, CD. Should I just pick all those things?
Those are the issues that I said in my hand.
Client apps, power project management.
If it allows whatever allows you to go through, just see. But if you can't go through, then we have to open in your account.
I have a question, Mr. Akin.
Yeah.
I'm at work anyway. So I set up my GitHub account, I believe, early this morning. So in terms of how many number of collaborators or so, I believe I chose one, so I made.
Yeah, one is good. You are good. You are
Did
good.
I
It
have,
will work.
okay. All right. Thank you, sir.
It will work. Yeah.
Mr. Akin,
Is
you're talking
that
about
you get additional teacher benefit or free, right? Or free?
Yeah, free. Of course. Now, what did you expect? You expect to ask you to pay? When you have free option, then take it.
like
Yes.
if you put up the student, so if you have a student email.
Yeah, if you have a student email, yeah, you may use student. But I've not really used this, so I'm not able to. I don't know what may come up. Yeah.
It says the home for developer includes you. It says create repository, import repository, register now.
Have you signed in, or have you completed your sign up?
Yes, I've done that.
Wait for us now. Wait for us to.
Okay, I thought I was still doing it.
All right, so we're ready. You are ready. Who else is ready to complete sign up so that we can sign in together?
We're ready.
Okay, good. So you should see this now, right? So this time, instead of sign up because you already signed up, we're going to say sign in. Enter your email address and password, and then you click sign in. So that's the digital account. Everyone signed in successfully?
Yes, I will sign it.
Good. All right, so that's it. You now have a digital account. You can now collaborate with them. In fact, you can collaborate with me right now. So that's good on that part. So you now have access to a repository. Good. So let's go to our. You remember your VS Code? Open your VS Code environment, your version control system. That's what we're going to use. So this is our, what's the meaning of VS Code? It's an IDE, integrated development environment. So this is the environment where we'll be interfacing with developers. And actually, basically like do our work. All right. Are we all here now?
Yes, sir.
Okay, so at this point, maybe you just watch me. I mean, I just wanted to make sure that you successfully created your GitHub account. So since you passed through that, at this point, you just watch and then say, you can repeat this. Okay, so let's set up a project. First project to use. I have so many projects here. So what's your class? Your class is this November. Let's create a folder for you. Where do I have DevOps project? So let me create a new folder, and call it November class. All right, so your project will be in here. All right, so this is what I'm going to do. I'm going to come to files, open folder, and then let me go to November class, and this will be the folder that I'll do your work on. All right, so we are now operating from your folder, November. All right, so you remember how to open your terminal, new terminal, and then we are not Windows people, we are Ubuntu people. We'll come here, I will say, give me my Ubuntu terminal. All right, what did I do? Awesome. All right. If I want, I can delete that. I hope I told you right. Okay. All right, so we are ready now. Everyone knows how to get here, right?
No.
Yes, sir. Oh, sorry.
Who does not know how to get here to this ID?
Yeah. So I just, you know what, my account locked, but I just created my new password because I have it already before. We'll put it to you. The GT, but I just did that one. As I was doing that one, I was not.
Yeah, as long as you had it, it's the same thing. The way to access it has not changed. So after class, we can just
okay, it just this. Okay.
Oh, look, just follow class. We can discuss there.
Oh my God. Okay, no yes.
Hey.
Okay.
Alpha.
Yeah. So let's go. Now, I'm first of all, we're running Ubuntu. Ubuntu is the version of Linux that is so friendly and has so many things already packaged, so many packages already configured within it. Unlike Linux, where you have to manually install many packages on your Ubuntu is industry friendly. All right, let's go. What tool do I need to be able to, in fact, oh, sorry, we didn't complete the setup. Sorry, we are going back. Let's complete setup in our GitHub. Let's go back. All right. So let me show you how to. I'll just follow this. No. Okay, so let's go to GitHub, and then we're here in GitHub. So for my account, I'm going to come here. In fact, let me. All right, so I can just look. So I'm going to come to settings and developer is highlighted there. Settings to developers, settings, then developer settings. So I come here, haven't logged in with my username and password. I come here and I look for settings. That's settings, right? And then I go to developer settings. I'm looking for developer settings. So let's scroll down. Let's scroll down. Do you see it?
Yeah,
right
the
here.
last one.
Okay. So developer settings. And what I want to do is create my password. Password for entering, for accessing my GitHub repository, not the account. You already have your account username and password. So for repository, password. But the password is called personal access token. This development started like 2 years ago. All right, so you click there. I guess I'm talking. So we say personal access token. Oh, okay, because I already have one.
You didn't get the developer setting.
Here. Here. Under settings.
Settings.
Then you scroll down, and then you find developer settings.
It's always the last one.
You see it now? So developer settings, and then you go to personal token, and then in your own case, token, you see something different. I already have the token, so you click token there. Well,
Thank you.
All right.
So, sir, are you going to generate new token?
Yes.
Yes.
You are going to click
generate new token, right? For new people, like for new. Okay.
Yes.
He gave us 2 options. He said fine grain rep. He has 2 options.
What are the options?
He said generate new token, beta, fine grain, repos, code, and the other one is generate new token, classic.
You should be seeing
one
a
is
like
classic, one is beta.
New personal. Hold on, everybody. Hold on. Please look at my screen. Look at my screen so that the questions will read. What do you see? New personal token access.
New personal access token.
Then note, enter your name, enter a name that you want to, just any name like that. Class practice, and then select scope. All right, so did it generate token for you?
When I click on that, mine is asking me for a password. So I just put in my password for GitHub.
Yes, try that.
So, sir, from the general new token, we should use the classic, right?
Look at my screen.
No, I mean from the one that was.
Yes, it is the classic. It is
It's the
classic,
classic,
general
yes.
use.
It is classic. Now they develop their system. They have a beta and they have a classic. So for us,
We will
in
not
this
take
class,
you to.
but if you want, if you have a money, you can go to beta. You know, some people are rich.
Yeah, beta will generally mean test mode, not fully commercialized, not fully, what's the word? Not fully tested yet, so it's still in the test mode. It's not fully released. They're still getting feedback to improve on. All right, so it'll be classic, which is supposed to. All right, so anybody generate token, something like this?
So what do we select for the scope?
Right? Expiration too.
Yeah, I did the expiration and then no expiration, and then it gives me a list of scopes.
Okay, scope, okay. Yeah, just select as many as you want to select. Is there administrator for everything? Is there a scope for administration? I should have had that. Select as many scopes as you want. If you want, select everything to allow you to do everything. But you can always go back there anyway.
Okay.
Is there a single administrator selection?
No, no.
Okay.
There is repo, workflow,
Yeah,
package.
select as many of them as possible. You can always go back to modify. All right, so I'm going to capture that and put it.
So, sir, there's a place that says delete packages. Do you have to omit that one or click it?
No, you don't have to, but if you want, you can just add it. Yeah, quickly get that right so that I can go to print it. It's actually optional to select this. It's optional. It will still allow you work anyway, even if you don't see it. So, do we have any token generated now?
Yeah, I think I've generated mine.
Awesome.
Yes,
So
sir.
save it, copy it and save it like I saved mine here. With your password, if you lose it, you'll not be able to access the system. You need to generate it. All right, so that's your password, and you will see how it is used now because Git will always be fine. All right, so now that you have that, let's go to our VS Code and start to use Git. All right, so we're in our VS Code. Maybe I want to work as sudo Akin. Switch user to Akin. All right. When I come to a new system, I want to do sudo yum update, right? Apt, sorry. This sudo apt. This is the Ubuntu, not Amazon Linux. Okay. So I've updated my system. Then upgrade. I don't really need upgrade. Let's see. It's just preparing my system for this. All right. So let us install Git on this system. Like I said, Ubuntu will normally come pre-configured with most of the packages. But if it wasn't pre-configured, the command to install Git will be sudo apt install. All right, sudo apt install. But Let's see. Is Git already installed? Let's see. What's the command to check? Git minus version. All right. So Git is already installed. Awesome. But if it wasn't installed, we have the command to install it. All right. Now, what is the command? What is the repository? In other words, what's the Java code that I want to replicate on my system? This is the tool that I'll be using for all of that. So I already have it. Awesome. So I have my Git. So what is the code that I want to replicate locally on my system? So let me go back to my repository, and then I do my repositories, and then I check all of, I have 6 repos. The one that I want to clone now is code demo. Okay, I remove the other one, right? Okay, so let's do this. Let me clone this. So this, I have to clone it. I'll take this, and you also can clone this. You can clone that. Can you see this? In fact, in your own Git, you can look for it's public. My repository is public, so you can connect to my repository and clone it. In fact, I'll just give you this URL in the note. I can clone it. Control C, and then I'll tell you. Oh, it's already here. Project codes. Is that the same thing? DevOps code. Let's clone this one. Let's clone the one in the note. Let's clone the one in the note. All right. How do I know project? No, I don't want to clone project. Let me clone. I have many repositories. Let me clone a simpler one. Code demo. Yeah, this one is good enough. So this has to do it. I go to the demo that I want to clone. Let me Control C. So let me not confuse it. Sorry about that. So I come here. Can you see this code? And I copy HTTPS link. Look at it here. I copy it.
How can we copy it, sir?
Look at it. I just click copy. Oh, how can you?
From
The
our
URL.
end.
Let me. Okay.
Is there a way we can get the notes so that we can
Yes,
follow?
of course. If you are paid, I'll send you a note. Control. Yeah, you always have notes to follow class. It's just that this is the first demo. You should actually be watching.
Okay.
And asking questions. Then, when you watch the video on your own later and you have the note beside you, you can now practice.
Okay.
Yeah. As for this link that somebody was asking me, no, you are not doing it now. I'm going to give it to you in the note, just like I'm doing now.
Okay, that's what I'm going to just to confirm.
Yeah. So I just giving it in the note. Okay. I'm going to just emphasize it. All right. So the command to clone, as much as possible, DevOps is about documentation. So I will not just be copying from my note. I will be telling you how I got it into my note. All right. So I will come here to code and I'll click this link. It's always there. So I click this link and I go back to my repository, my CLI, and I enter the command. Git clone, that is the command. It means copy the Java code as pushed there by the last developer. Git clone. Then clone what? Clone what I copied there. So I just right click to clone. That is the repository I want to clone. Then I press enter. Git clone, cloning into demo error. Shimon. Oh, okay. Something I did about it. Cloning these, Gmod, MTN, the operations not permitted. I've done some configuration. Okay, so I'm not sure. Maybe that's. Let me try another repository before I conclude that. So let me try a different repo. So I go to the DeLighter. And then let me try DevOps code, DevOps class. Which one did I? DevOps code repo. Oh, okay.
That
So
one
I
can
go
still
to,
go.
yeah, maybe I didn't ask sudo. So this one, right?
Yes, yes, you have, let's sudo it.
Sudo git clone.
Yes, let's see what's going
All
on.
right. All right, yeah. So yeah, we should have just added sudo to that last one. Anyway, so this is how to clone. So it's cloning and making the cloning basically means replicating the copy that I have of in cloud on my system. So look at it, it's now represented. All right. So this is the Java codes that was built by a developer and pushed to GitHub. So I've now made a copy and I have it in on my system, so I can start working with it. All right. The next thing I want to do.
I don't mean to take us back to Linux. Why do we need sudo again if you have switch user working from the root?
I'm not working from root. I'm Akin.
That's not the root.
All
That's
right,
not
I
the
see.
root.
I just get it.
Yeah,
Thank you.
yeah. If I wanted not to use, then I'll just say sudo. Sudo. Yeah, I have that option not to use sudo. All right. So
what is the best option to use? Is it from the root or just
root is fine as long as it's your system. Root is fine. For me, I'm just trying to get used to not forgetting this sudo. So I deliberately punish myself. Get used to using sudo. All right. So the next thing I want to do is I want to. I don't need this anymore. Okay, let's see. So I have that clone. So what do I have now? ls minus la. So I have that. So this is my project. So cd DevOps demo ls minus la. Yeah, I have my project. So the next thing I want to do is initialize JIT on this project. Actually, it's already done, but normally what I should do is do JIT init, just like we did with JIT init. It means initialize JIT so that I can begin to use JIT on this project. And as a matter of fact, what is more important is it means create a local repository. Create a local repo. What I have here right now is not the local repo. It's just the working directory. It's the working directory. But to create a local repo, I will need to do git init. So when I do git init, again, I keep forgetting sudo. Should have been sudo. Or if I know that forgetting sudo will be a problem, I better just change the root. Right? So it says reinitializing existing git. Right? But it's just because it's already there. How do I know it's already? How did I know it was already there? Look at it. .git. This is the directory where git keeps a local version of this. All right. So now, what else do I want to do? I want to, let me show you. If I run this command, git config list, my own case may be different because I've been using my VS Code for so many. But if I run that command, okay, my own case is already set up. In your own case, this one will not be set up. I have been using my own environment for so many practices. I had a class that I just completed. All right. This one is not set up. So in order to connect your VS Code environment to your GitLab, sorry, to your GitHub account, so that whatever you are issuing, whatever command you are issuing here relating to your GitHub, it will be able to connect and do stuff for you. The command to do that is these two commands. What do? They connect your VS Code. In our case, we're using GitHub account with your VCS. Connects your my ID environment with my VCS. So the command is git config -- global username. What's my username for my account? theITern. And what's the email address that I use to create that account? The ITern at USA. So I just either type that or copy this, Control C. Then I put it there. All right. Let me sudo what? Sudo. All right. So I'm working as root now, so there'll be no need for. All right. So user. All right. So that one was already there. That's why it's giving that error. Git config --, so it's the same thing. And then I say provide the username, I mean the email address. I go back there and I say user. All right. So what have I done? If I now do enter the command git config --, list, it's going to tell me that my VS Code environment is now linked to my Git GitHub. Right? You may not understand the rest, but this true is what I'm looking. All right. Any question? You can actually relax here and stop here and revise what we've done so far, and make sure you get what we've done so far. How to create a GitHub account and how to link your VS Code environment to your GitHub. Just like we have. Like I said, I would normally copy and paste from here deliberately just to show you that the note is working. So this is what we have stored today. And where it is necessary, I'll tell you how I got the link or how I got what I have in my link. As a matter of fact, everything about Git can be linked directly. Maybe not everything, but most things about Git can be linked directly from here, from your GitHub. Like you will see. All of those commands, they are mostly around. I'll get them from all of those Git and GitHub, they are brothers and sisters. All of this importing stuff. All right, guys. So, is there something you have not understood so far?
How you was able to link the account? Probably the video will do justice.
Yes. So to link the account, this is just these two commands. That's it. These two commands in yellow. Those are the commands that I need to use to link my VS Code with my GitHub account. So I say
so
the
do
command
one after the other, right?
Yes, one after the other. Yeah, that's why the paragraph sign is there. So the command is.
Actually, I copied a different clone URL on the GitHub website, so I'm lost from there. So another thing is whoever knows how to download Ubuntu on Mac, because today I'll be traveling, so I'll be taking my Mac. I can't take my Windows. They should please help me.
What do you want to download?
Download Ubuntu on my Mac, because from next week I won't be.
Yeah, just let me know. There's a way I can run you through that. That's no problem at all.
Thank you so much.
Just contact me, then I'll help you set it up.
And who is speaking, please?
My name is Yomi.
Okay, Mr. Yomi. Okay.
Awesome. That's good. Okay, so like somebody was asking, these are the commands.
A lot of Mac users, so we'll be fine.
That's cool. Yeah, I think I saw. It must be him. I saw the volunteer that really helped when you had that Mac issue. I was holding private meetings with you. Awesome. Whatever.
Thank you.
All right, so those are the commands to link you, and that's why we're stopping today, so that we don't learn too many commands in one.
So do we need to destroy anything there?
Do we need to destroy anything?
On our VS Code?
No, nothing to destroy.
We are not on AWS.
You're not paying for any infrastructure.
Bro, the fear now. We're gonna go knock and beat.
This is your local system.
That one a good question. No, it's too early to be getting built.
Now, where does the token comes in here? Because I never saw you use it, or probably I missed it or something.
No, we have not reached there now. Don't worry. You use token time. We'll get there.
Sir, if nobody asks question, I have one question, sir. I want to ask.
Okay.
It's always very easy for me. Maybe I'm lazy, kind of. It's always very easy to use fork. Is it proper? I'm sorry if I'm asking this question in this class. Is it proper?
No,
for
it's proper. It's fine.
To fork and now get my things done.
Yeah, it's proper. It's fine.
Okay, thank you, sir.
Well, I don't know if you have noticed, my own way is to first of all teach you the normal and hard way. Because when you run into a problem, you should know the hard way so that you can troubleshoot. And then once you are comfortable with that, I'll come back and show you the simple. If I show them fork now, nobody will want to go through this hard way of using command.
Hard way is always a very sweet way.
Yeah, you'll be using fork a lot. There are more repositories than this that we'll be working with. But once you can prove to me that you now know how to clone, and then how to push your changes back to the repository, then I'll now show you how to. All right. It's not bad, it's a good thing. I mean, it's there for you to use. Any other question? We've covered so much in one day, actually, so not a bad start.
When are you going to share this manual again?
Today, only with
work,
people
so I
who
can have to.
Where you pay more?
Yeah, so I'll be able to practice when I get home because I'm at work now.
Yes. So if you still don't get it by 10 o'clock today, please send me a message. When you send me a message, I'll look at our thread and see whether you deserve.
Yeah, I've paid my own full anyway. Thank you.
No problem. What's your name?
Babajide Adishaka.
Oh,
okay.
Like. Yeah,
I want.
Yeah.
Yeah. So I'll get my own this evening.
Okay, yeah. Ramasale, you have a brother here now. There's Ukina Meme here.
Araba.
Yes, questions.
So CJ from that end too. Okay.
You said?
Mr. Ukino.
Yes,
from owners. Which state are you?
Edo State, Ekboma.
No. Here in the US.
Oh, I'm in Texas.
Okay, all right. Just curious.
Yes, sir.
This one that Mr. Akin is connecting both of you, now you are speaking in tongue. No problem.
That is the real That is the real
That's the networking now. So when one gets done, pull the other one.
I know it's part of it now. Me and Jide here in New Jersey too, we connected.
Yeah, and Jide.
Who is in Ohio?
What's your name?
You have two Jides here now in your class.
Okay, so Baba Jide and who? Yeah, Jide.
It's so funny. It's also Baba Jide, but he decided
he knows me.
Jide is always Baba now. Who else is going to Jide again?
No, it's Ola now. There's Ola, but Baba is so common.
Okay.
There is Ola Jide, there is Olu Jide, but Baba is so common than the rest of the other prefix.
Yeah. Awesome. All right, so you guys are happy with what we've done today so far?
So far we just opened the JIT, and I think from the notes we're able to, I don't know. I just know that we opened the thing. I think we were able to do some other things, but probably the notes will explain on the video.
Yeah, but if you understand to the point of opening JIT, yes, you're good. Because we'll definitely be repeating these things over and over.
Yeah, because I already understand the JIT, but when you went to some things you did there, I don't, probably because it's a little bit faster.
Don't worry. Yeah, because it's implementation. Don't worry, we'll do it again and again and again and again.
That won't slow us down or anything.
No. We have enough time. We have the month is enough to cover all of the tools we want to learn. So what else? Yeah, ask questions. And then, of course, at this level, we'll begin to talk about interview questions more often.
So I want to ask a question. I saw one of your Instagram stuff, and you were like, from next year, the DevOps will be free. So why is our own not free?
So yes, from next year, the DevOps will be free for online training. In other words, I will not be there physically. I'll just forward recorded classes to them. No support, no. So it's a different program. And then, of course, being free is marketing. So what it means is that I'll actually spread the cost of DevOps across the other courses. So they pay for 3 courses and get 2 free. So no effort, just no effort on my part. It's not like your class where we're here discussing, we're laughing, we're having this one-on-one.
They would have options of going for the free online one or the.
Of course, yeah. Okay. And many people, in spite of that, many people still prefer to have this live class.
Of course, okay.
I have not had one single sale on that, but I've had many sales on the regular fee.
So is there plans to change the next month on to weekdays?
For which course?
For the DevOps too.
No plan, because I'm the only person that takes that course. There's no other person, and I'm free only for weekdays.
Oh boy.
Yeah, for now, no plan.
So I send a receipt to you through the WhatsApp from Moses.
Okay. I'll see it after class and I'll reply accordingly.
All right, thank you.
Yeah. Yes. All right, so I'll release you early so you can complete the setup of your facility and start the process. And then, of course, read the list. You need to be boring to read it. You need to understand. Read the diagram, all right, guys, so let's come back here. What's today? Next week, Tuesday, and then we'll complete JIT, and then move on to go and start building codes. All right, with Maven. We'll complete JIT, we'll move to Maven. Complete Maven, we'll move to Maven. Yeah, move to Jenkins. And then we'll do a lot of stuff in Jenkins. And then once we're able to get an artifact in Jenkins, we know where it is hiding. We're able to make a copy of it, and then we'll deploy to Docker. And then once we see it in Docker and we're happy, then we'll go and deploy to Kubernetes. And then once it's deployed in Kubernetes, we're happy. We set up monitoring tools to tell us how our application is working. And with that, we are ready to go into the wall.
That's what I'm saying.
So, sir, all the things you're going to build this month, you are not going to set them up yet, right? Is that what you're saying?
We're setting them up from scratch. So we'll be doing them one by one.
I was hearing you say when we get to Kubernetes, that's when you set up. I don't understand that part.
We'll set up Kubernetes from scratch, set up Docker from scratch, set up everything. So we have empty servers, right? In fact, we have never set up servers. So we'll be building them from scratch. So when I say when we get to Docker, I mean, we are going to set up the container using Docker, and then we'll learn all of the commands. And then we'll deploy the app that would have built with Maven and Jenkins. We'll not deploy it into Docker. So it's not there already. We'll build it by ourselves. It's in the process of building it that we'll gain the experience. I don't know if you answered it. All right, guys, let me let you go 10 minutes earlier, unless you have questions about it. I see there.
Guys are still here. They are, all of them are just waiting. Yeah.
Okay,
I guess most of them are still trying to clear themselves with migration.
Okay, no problem. All right, let's continue next week Tuesday, guys. See you on the forum.
Okay, sir.
All right.
now.
Good night.
Bye,
Thank
everyone.
you.
Good night. Good seven. Bye.
Thank you, Mr. Akin. Good night.
All right, Timmy. Bye bye. Timmy, the guy who just joined today, right?
Today's my first day.
Yeah. Okay, I remember. Yeah. How did it go? Did it go?
Oh yeah, I really enjoyed it.
Oh, okay. I thought you say you are not covered. That's good. If you could cope today, then you'll be able to cope.
Yeah, I was able to cope. Thank you. I'll text you also for the notes as well.
Okay, no problem.
Yeah. Thank you, sir.
Right.
Good night.
Yeah. All right, good night.
Thank you, sir.
All right, good, bro.
Thanks.
Bye, everyone.
Good night, sir.
Good night, sir.
Good night. How are you doing?
Good night.